Okay, so, and I need to share the screen. I will tell you that Module 3 and 4, I'd love to tell you they're going to get easier, but quite honestly, they don't, because it builds on itself. But I'll also tell you that the Module 3 exam and the Module 4 exam are going to be taken within D2L without proctoring. So you'll be able to use your notes and the resources that are available in D2L. So that may be to your benefit. Personally, I would strongly encourage you to take detailed notes over the course of the next lessons through Module 3 and Module 4, and keep them organized so that you are able to readily find that information when you are taking the test, okay? It's also true that the final exam, it'll be taken paper and pencil, and you'll again be able to have the one 8.5 by 11 sheet of notes for the final exam. So again, keeping it organized may help you to know what to put on that piece of paper should you opt to take the final exam. Okay, so we are going to use Minitab a little bit later today. So if you want to log onto the computer for that, you can, or you can just watch. It's up to you. But we're going to begin Module 3, and there are, at the beginning of Module 3, we have introduced or added a new component where we talk about a particular theorem or some theory behind what's going on. I will tell you, in relationship to this theory, there are no practice problems, there are no homework problems, and there will be no questions on the actual test itself related to that particular topic. But you need to kind of know, it's kind of like you need to know the rules of the game in order to play. And so this is kind of one of those rules of the game that you need to know. And so the topic, which hopefully I can put back up on the screen in just a minute, is the central limit theorem. And we abbreviate that usually CLT. You might see that abbreviation somewhere. Let me see if I can get this back up again. And again, it's theory. And what you have to realize is that up to this point, and honestly, I don't remember if we talked about it. I talked about it in one of the classes or a couple of the classes. And so it all gets meshed together after a while. But at the end of Module 2, when we were looking at the normal distribution, all of the problems that we talked about said something like if one subject, or if an item, or if one thing was selected. Okay, so it, okay, looks like I'm frozen here. Let me see if I can, hold on just a second. Let me get all this going back on again. Yeah, I don't want to be difficult. Okay, so we looked at the end of Module 2, we were looking at where we were looking at a single item. Well, if we choose just a single item, think about how much it can vary, okay? Think about how much it can vary. Make sure I'm still recording, okay? For just one item, okay? So the difference in kind of the piece, couple of things you need to know about the central limit theorem is the central limit theorem, we are going to select a group of items or a group of individuals. Instead of looking at a single, we're going to look at maybe 10 or 20 or 30, because our belief is that a group would tend to vary less. They would have those commonalities more so than if you looked at one individual or one item. So we select a group of items, typically of size n. Okay, and that the n could be, we could do, so we're going to choose 10, we're going to choose 20, we're going to choose 100. It could be any number. Okay, so we're going to choose a group of items of size n. And so what the consequence of that is that the items vary less, in theory. And so we adjust, oops, sorry, I spelled that wrong, adjust the standard deviation. Now, if you watch the video that's embedded in D2L for the topic of central limit theorem, it gets really kind of deep into this theory. Okay, so I'm kind of giving you the quick snapshot here. But again, the idea is with central limit theorem, we're going to choose a group of individuals instead of a single or one, and with the thought that they're going to vary less. And so we adjust the standard deviation. So the notation for this is you would have the standard deviation, and for a group, we put a little subscript of X bar. Now, this is all going to go on behind the scenes, so you don't really have to remember all this fancy-dancy notation, but just so you can say, well, Miss Ralston did show me that at one point. Okay, so we adjust it. We take the original standard deviation, and we divide it by the square root of our group size. Okay, and so, and you'll find every time you do that, that standard deviation gets smaller. Again, the idea that it varies less. Okay, so that's one important piece of the central limit theorem, is that you're going to be selecting a group of items, and because you're using a group, you adjust the standard deviation. The interesting thing, though, is that the mean of this group is the same as the mean of the original, so it doesn't change. The other piece of the central limit theorem that's kind of important that will come into play, and again, all this is going to go on behind the scenes. Minitab's going to take care of it for you. It utilizes the central limit theorem. It's in its program, so you don't have to actually do any adjusting yourself. The other thing about central limit theorem is we can take any distribution, whether it is a uniform distribution, whether it's skewed left or skewed right, and by applying the central limit theorem, we force that distribution to become normal. Okay, so any distribution, the data can have any shape. It can be uniform, it can be skewed left, skewed right. You might have some kind of two-humped looking thing, but any distribution that you have, you can, in a sense, force to be normal by applying the central limit theorem and selecting a group. So then that opens up a world of possibilities, because the normal distribution is one of the most useful throughout the realm of statistics. Okay, so those are kind of some rules of the game that are going to go on behind the scenes, okay, that you need to know about. Again, there are no homework problems, there are no practice problems, and there are no questions related to the central limit theorem on your test. Okay, again, it's kind of just, you got to know the rules of the game. So as we move on into Module 3, we're going to be talking initially about what are called confidence intervals. And I want to try to give you a quick overview, again, kind of that quick snapshot of what a confidence interval is. Okay, But to get to confidence interval, I want to backtrack for just a minute. If you go all the way back, almost to the first day of class, we looked at the idea that statistics is the whole process, the science of collecting, gathering, organizing, analyzing data. And we talked about that there were two different branches of statistics. In fact, that was one of the questions, I think, on your test. We had descriptive and we had inferential. Remember, with descriptive, we are simply stating just the facts, like the fact that there are 6 students in the classroom, that 3 of the students are male, 3 of the students are female, 2 of the students are wearing hats, none of the students are wearing glasses. Okay, we're stating facts. We could figure out the average age, or we could figure out the median, we could figure out the mode. Okay, so we can describe the data set, basically using just the facts. And that honestly has been the focus really throughout the end of Module 1 and throughout Module 2. As we move into Module 3 and Module 4, we're going to get into the inferential. Remember, the inferential side of statistics is where you begin to interpret the information. But in order to interpret the information, we do have to make some assumptions about our data. Remember that kind of the whole idea, the whole process here is we take a sample, a small group, even when we're doing descriptive statistics, we take a small group and we learn everything that we possibly can about that small group. And then we use that information about the small group and we apply it to the big group, or we infer it. Okay, so we talked about that early on as well, how we take what we learn about the small group and we apply it to the population. And that gets us into the realm of inferential statistics. But remember, you can't really do the interpretation or the inferential side of statistics without the descriptive. You've got to know the mean, the median, the standard deviation, the range, how many you sampled. So you have to know all that. And so we take what we learn about that small group and apply it to the big group. So we're getting into that realm of inferential as we move into Module 3 and Module 4. In Module 3, or excuse me, not Module 3, but in Module 2, we've been calculating things like the mean, the median, the mode, the range, standard deviation, the variance. Those values are what we call point estimates or point estimate, because we were calculating a single value based on the data we had. We were calculating a single value to represent the average or the standard deviation or the median or the mode. Okay, but as we move into Module 3 and begin talking about confidence intervals, we're going to create what are called interval estimates. The interval estimate, the difference is, instead of using a single value, we're going to create a range of values. And you may think, well, Ms. Ralston, why would we do that? Why would we go from using a point estimate to an interval estimate? Kind of think about it like trying to hit the target. Okay, our goal is to ultimately be able to use what we've learned about the sample and apply it to the population. So we take the sample mean, or the average, and we're going to infer it and say, well, since the average is 23 for the sample, we're going to assume that that is also the mean of the population. We're going to take what we've learned about the sample and apply it. But guys, think about it. That's one value. Do you really think that one value is going to hit the target in the bullseye every time, all the time? I don't think so. Because we can get different, if we use different samples, we might get different answers. And so our sample point estimate may not always be on target. It may not always be hitting the bullseye. So instead, we're going to begin using this interval estimate, or this range of values, which gives us a little bit more leeway for what the possible value says. It says, we believe that the mean of the population falls within this range of values, rather than saying it's exactly da-da. Okay? Those interval estimates that we're going to calculate are called confidence intervals. So that's how we get to confidence intervals. So let's talk about confidence intervals for a minute. Okay, confidence intervals. Okay, what are confidence intervals? The confidence intervals provide a range of reasonable values for the population parameter. Now, we're going to focus on the mean as our population parameter, but you can also create confidence intervals for the standard deviation, or for the variance, or even for the median. Okay, our focus is going to be primarily on the mean. Okay, so the confidence intervals provide a range of reasonable values for that population parameter. Gives us a better chance of hitting the target, or being on target, hitting the bullseye. Okay, it also gives us, again, that better sense that our estimate is on target. And it does that because we have a predictable probability of success. Okay, the idea of that predictable probability of success is a fancy way to say we're confident. That we can be confident at a certain level that our interval is accurate. Okay? I'm going to show you kind of the formula, again, that's going to go on behind the scenes, because we're going to let Minitab do the work for us. If you didn't have access to Minitab, you can Google and find free websites that will do it. Your calculator, TI 8384 calculator, will do it for you. We're going to use Minitab. But what we do is we take our point estimate that we learned how to calculate in Module 2. In this case, that would be our sample mean. And then we add or subtract what's called the margin of error. Okay? We take our point estimate and then we add or subtract the margin of error. We're basically saying we could be off by this much. We could be under by this much, that's the subtraction, or we could be over by this much, that would be the plus. Now, another term that you may see for margin of error, there's a fancy term for it. Margin of error is also known as the error bound for the population mean. Okay, so some text, some authors may use that terminology. We abbreviate that EBM, error bound of the mean. Okay, so you may also see it abbreviated in that manner. Now, your margin of error takes into consideration how confident you want to be and the standard error of the mean. Sort of standard error of the mean is just fancy terminology, similar to the idea of the standard deviation. How much do we think we're going to be off? Okay, now again, don't get caught up in all of that craziness. Minitab is going to do the work, and we're going to focus on what does that tell us? What does that mean? Okay, so I want to talk a little bit about the idea of the confidence level. How this idea of this predictable probability of success, how confident do we want to be? That's called the confidence level. Okay, it's called the confidence level. So we're going to talk about that for just a minute. Got to get all the pieces together before we can actually do a problem. Okay, so confidence level is the probability that the population parameter, remember which we're dealing with, the mean, is within the given interval. Or as I stated before, it's your probability of a success. Okay? The confidence level is the probability or the chance that the population parameter is within the interval that you're going to create. It's the probability of success. And in most cases, the confidence level is stated as a percentage, which is okay because remember, probabilities can be written as a decimal, a fraction, or a percentage. And typically your confidence levels are stated as a percentage. Now, there are some confidence levels that are most commonly used. The three most commonly used confidence levels are 90%, 95%, and 99%. Those are the three most commonly used confidence levels. I'm going to put CL above it, so you'll know those are confidence levels. Okay, and again, that means you're thinking about it from that positive perspective. What's the probability, to say that I have a confidence level of 90% means that I am 90% confident that the mean will fall within that interval. If I say I'm 95% confident, that means there's a 95% chance that my mean is going to fall within that given interval. Okay, so it's, again, thinking about it from a positive perspective, and it's the probability that you're going to have a success. I hope you realize that if there's a probability of success, on the flip side, there has to be the probability of failure. There has to be that chance that I'm not right, that I failed, that it's not within that interval. Okay, so let's talk about that for a minute and think about how those two things are connected. Okay, so confidence level is the probability that you're correct, that you have a success. But on the flip side, we could have a probability of failure, that we're wrong, that it's not within that interval. And if you'll remember some of the probability rules, remember probabilities total to 1 or 100%. So if I'm 90% confident that I'm correct, what's the chance that I'm going to be wrong? Obviously 10. It's 10%, because 100% minus 90%, you have 10% left. So there would be a 10% chance that I would be wrong. If I say I'm 95% confident that I'm right or have a success, then I'm going to have a 5% chance of failure. 99%, I would have a 1% chance of failure. From a statistical perspective, the idea or that probability of failure is called the significance level. Okay, you can kind of think about it. You have confidence level. How confident are you in your answers? Probability of failure, we call it the significance level. And so it's like, how significant is it that I'm wrong? But typically, one of the differences here, the significance level is usually stated in decimal form instead of as a percentage. So if I think about converting each of these to a decimal, I would have 0.10, 0.05, and 0.01. And we also have a special symbol for this probability of failure or the significance level. It's the Greek letter alpha. Okay, and you'll see that a lot as we move on. So the significance level is denoted by the Greek letter alpha. It's called the significance level. There's not a fancy symbol for confidence level. Usually we abbreviate it CL. Now I mentioned that, again, it's just your perspective. Are you looking at it from the perspective that you're correct, successful, positive, or are you looking at it from the negative side, that you have failed or have been unsuccessful? As we move further into Module 3, as we get into hypothesis testing next week, we talk more about the significance level. Okay, so you'll already have some insight into that particular problem. Okay, so There are two different types of confidence intervals that we're going to talk about in this course. Overall, the process for finding them are the same. It's just a matter of knowing which one to use when. So let's talk about that for just a minute. Okay, so kind of our overarching theme here is confidence intervals. And again, specifically for us, we're focusing on how to find confidence intervals for the mean. And there are two different types that we're going to focus on. You have what we call the Z interval, and you have T as in tiger interval. Okay, typically we use the Z interval if our sample size is greater than or equal to 30. Or we know that our distribution is approximately normal. Now remember, our normal distribution is what we looked at the end of Module 2. You have that horizontal axis, your bell-shaped curve, and the mean is in the middle. So when you have a large sample, greater than 30, the distribution is approximately normal, and you know the population standard deviation. Okay, this is the key. This is the very most important, super duper important part of what I'm telling you. If you know the population standard deviation, you will use the normal distribution or the Z interval. In these problems, the way that they're set up, at least in this course, now I realize they're a little bit contrived in the course because they're set up where they're easy for you to follow. In the real world, you would have to do all of the descriptive statistics yourself. Okay, but to make it a little bit easier for us, in these problems, you're going to be given 4 things. You're going to be given the sample mean, which is X bar. You get the population standard deviation, which is sigma. You get your sample size, which is n. And you get the confidence level. Okay, so somewhere in the story, in the paragraph related to this question, you're going to get all 4 of those things. All right, now let's talk about, for a minute, the T interval. Okay, let's talk about the T interval. The T interval, I'm going to change colors here. The T interval is typically used when you have a sample size that is less than 30. Remember, we talked about that being a small sample. Okay, so when your sample size is less than 30, you're most likely going to use the T interval. It's also true that the distribution is approximately normal. In this case, you know the sample standard deviation. Okay, that's the difference. Okay, the difference between the two is for the t interval, you know the sample standard deviation, not the population. That's how you tell the difference. For the t interval, we use a different distribution that we haven't talked about yet. So I want to kind of give you a little bit of background on the distribution. The distribution we're going to use here is called the student's t distribution. And it has a lot of the same characteristics as the normal distribution, okay? Visually, it almost looks the same, except the student's t distribution still has that bell-shaped shape. It's still symmetric so that the left side is a mirror image of the right side. What is different about it is that, and I purposely drew it this way, it doesn't taper off as fast as the Z. So you have more area in the tails for the student's t distribution than you do for the Z. And again, I drew it purposely so that this one looks close to the horizontal line and this one doesn't, because that's the way it looks visually. The student's t distribution has an interesting history. Was actually developed by a guy who worked for a beer making company in Germany. He realized when they were sampling things that they were using small samples. You know, instead of using 100 samples, maybe they were only using 25 samples. And so he realized that the normal distribution really didn't apply to what they were doing. And so he began studying and working, and he came up with the t distribution. But his employer would not let him publish his findings for fear that somebody else might find out what they were doing in terms of making their beer. And so instead, he used a pseudonym, much like Mark Twain uses the pseudonym, or Samuel Clemens uses the pseudonym Mark Twain. And so the pseudonym he chose was student, because he was a student of mathematics or a student of statistics. And so that's where the name student's t distribution comes from. But again, the main thing to remember is that it has that same basic shape as the normal distribution. It just doesn't taper off as fast. The other piece that's not overly important to you as far as working the problems, but remember we had said that the normal distribution, the shape was determined by the mean and the standard deviation for the normal. For the student's t, what controls the shape is really the sample size, but it's called the degrees of freedom. So the shape here is determined by the degrees of freedom. And you may think, well, Ms. Rawson, what is degrees of freedom? And we usually abbreviate degrees of freedom, DF. What does that mean? Basically what that means is that tells you how many of the data values are predetermined, or not predetermined, excuse me, how many of the data values could be randomly picked before the last one becomes predetermined? You know, if you've got 4 quizzes in a class and you know what you made on 3 of them, you can figure out what you need on that 4th one, maybe to get an A in the class or to get a B in the class. Okay, so you have that, you would have 3 degrees of freedom because the first 3 test scores really doesn't matter. The one that's really important is the last one. Okay, so that would be 3 degrees of freedom because you had 3 choices, 3 to choose, but 1 becomes predetermined. So that's the idea behind degrees of freedom, which is really associated with the sample size. And again, that doesn't affect you working the problem. So the other thing is we get the same information almost for the T that we get for the Z. We still get the sample mean, we still get the confidence level, we still get the sample size, but we get the sample standard deviation instead of the population, okay? These problems are going to be, I mean, in my opinion, they're obvious and they're straightforward. Biggest thing you're going to have to pay attention to is, do you know the population standard deviation or do you know the sample standard deviation? Because that's going to determine which one you use. Everybody okay? All right, so we're going to take a look at some examples. And we're going to let Minitab do the work for us. We're not going to calculate things by hand. There is one piece that we're going to have to do by hand because I realized last night that good old Minitab doesn't do it. Okay? So here's our question. It says, for a sample of 40 females, the mean pulse rate is determined to be 76.3. Assume the population standard deviation is known to be 12.5. Construct a 99% confidence interval for the mean pulse rate of women. Okay, so the first thing I would do, guys, is identify my information. Okay, I think about it like identifying the players. Okay, we need the sample mean. We need either the population or the sample standard deviation. We need our sample size and we need our confidence level. All 4 of those things are given in the problem. So I'm going to go back and read again, and each time I come to a number, I'm going to identify it. For a sample of 40 females, so I know that my sample size is 40. The mean pulse rate is determined to be 76.3. So the mean pulse rate is 76.3. Assume the population. Guys, look. Big, bold letters. Population standard deviation is 12.5, and it says construct a 99% confidence level. Once I've identified all of the players, I need to decide, am I going to do Z or am I going to do T? What do you think? I'm going to do Z because I was given the population standard deviation. So now I'm ready to go out to Minitab. I've got all my information. I'm going out to Minitab. And I'll write the steps down for you as we go. So I'm going over to Minitab. At the top of the screen, we're going to choose the menu for Stat. Then we're going to choose Basic Statistics. Okay, so you go to the top of the screen where it says Stat. Then we choose Basic Statistics, and then we're going to choose, it's the fourth option down, we're going to choose one sample Z. Okay, one sample Z. When you do that, the wizard comes up. Now, guys, there's a lot of choices you have to make here. The very first one, it says one or more samples, each in a column. Okay, that is the choice you use if you know or have the raw data. I don't have the raw data. So I'm going to use the drop-down box. I want to choose summarized data. So on the wizard, let me get a different color. On the wizard, I'm going to choose summarized data. I'll go back where you can write this down in just a minute. Okay, so then you have to enter the information. It wants to know your sample size, which was given to us because it said we had 40 females. The sample mean was 76.3. That was given to us in the problem. And the known standard deviation is 12.5. That was given in the problem. Okay, so after you get summarized data, then you enter the information that you have from the question. Okay, then we have to go to options. Okay, there's a little button on the bottom of that screen that says options. Here's where you tell it the confidence level that you want, okay? And this one we want 99. So I'm going to change it, 99. I don't have to put 0.0. 99. Then it says alternative hypothesis. Leave it as the default. It should always be not equal, okay? I'm going to tell it okay. Tell it okay. And then in the results screen at the top, let's see if I can make this bigger for you. Maybe. Maybe not. Okay, up here in the top, on the worksheet, you see the answers. It says one sample Z. And what you want to focus on is this last piece, 99% CI, confidence interval, for the mean. And we get the numbers. I'm going to write it up here at the top of this page. Okay, so we get the numbers from Minitab. And it says 71.21, 81.39. Okay, so we're going to copy those directly from Minitab. Okay, so let me go back for just a minute. If you want to make a picture or write it down, there are the steps for Minitab. I'll pause for just a minute. Okay, and then we pull the results. We got 70 parentheses, 71.21, 81.39. Okay, here's the deal, guys. this first number is what we call the lower bound. Okay, that would be the lowest value that we think the mean could be. The second number is the upper bound. And I make the distinction between the two, guys, because you need to be careful when you're looking at your homework and your practice problems, because it may sometimes say, what is the lower bound? Or it could say, what is the upper bound? So you need to know how to tell the difference, which if you think about it with common sense, it makes sense. The lower bound is going to be the smallest one. The upper bound is going to be the highest one. The other question they always usually ask is they want to know the error-bound margin. And I noticed last night as I was kind of getting ready for this lesson today that Minitab doesn't calculate that for us. So we have to have a formula. This will be one of the few hand calculations you have to do. Okay, here's the easiest way to do it. There's lots of different ways, but I think this is one way to do it, and it'll be easy for you, is you take the upper bound, subtract the lower bound, and then divide by 2. Upper bound minus the lower bound and divide by 2. Please be careful. Make sure you follow order of operations. Notice that I have parentheses around that top. So we're going to do that subtraction first. So I'm going to do that on my handheld calculator. So I would do 81.39, that's my upper bound, minus 71.21. I'm going to say equal. So I get an answer of 10.18. And then I got to divide that by 2, which is 5.09. So my error-bound margin is 5.09. Okay, the last thing you have to be able to do is to kind of summarize your results. Okay, what do your results tell us? And you really write the same sentence, okay, pretty much every time. And you can, kind of change up the wording a little bit, but we can say, we are 99% confident that the true population mean is between 71.21 and 81.39. Okay? Guys, watch the words. We are 99% confident that the true population mean, that's the phrase. The pieces that will change from problem to problem are your confidence, how confident you are, and then your results. Other than that, the wording doesn't change. We are 99% confident that the true population mean, we really should say the true population mean of the mean pulse rate for women or whatever we're talking about is between 71.21 and 81.39. The details, putting in the details is better. Okay, y'all ready? I got 14 minutes. I'm going to try to go through another one. Okay, this one says, a recent study of 25 students showed that they spent, on average, $18.53 for gasoline per week. The sample standard deviation of the sample was $3. Construct a 95% confidence interval for the mean amount students spend on gasoline per week. So again, we begin by identifying the information we need to work the problem. So we need X bar, the sample mean. We need the standard deviation, either the sample or the population, the sample size, and the confidence level. All four of those things should be stated in the problem. So again, if I go back and read, it says a recent study of 25 students, so my sample size was 25, showed that they spent on average, so there's my mean or my average, $18.53 for gasoline per week. The sample, again, bold letters, sample standard deviation is or was $3. And we want to construct a 95% confidence interval. Again, the first thing I should decide at that point is if I'm going to do Z or T. I hope you realize that in this particular scenario, you're going to do T because I know the sample standard deviation. The process in Minitab is the same, except you're going to choose one mean T because we decided we needed to do a T-test. So let's go back out to Minitab. So we would go, and again, I'll write it down for you. First time through, I'll write down the steps. We again go to Stat, Basic, Statistics, but we're going to choose one sample T this time. Okay, so I'm going to Stat, Basic Statistics, one sample T. And again, we have to make some choices. And for this problem, we're using, again, summarized data. And then you have to enter the information that you have that's been given to you in the problem. Our sample size for this case was 25. The sample mean was 18.53. My standard deviation is 3. Whoops. Get in the box. And then we again go to options, writing it down, to put in our confidence level, and you'll always use the not equal. Our confidence level was 95, which is the default, and it's already for not equal. So I say, okay, okay. And again, my results appear up here at the top, and it's this very last piece. And again, it appears in those parentheses. So I have 17.292 to 19.768. So I've written that down. And go back where you can get the notes, okay? It's the same process. If you want to write it down again or take a picture, there it is. Again, the first number, didn't want to be in your way. First number is still called your lower bound. The second number is still called your upper bound. Okay, the terminology doesn't change when you're doing T as opposed to Z. We still can find the error bound margin using the same formula. It's the upper bound minus the lower bound divided by 2. So for this problem, I would have, using my calculator, let's see what I get. 19.768 minus 17.292 gives me 2.476 divided by 2 is 1.238. So my error bound margin is 1.238. Then finally, at the last step, we write our conclusion. The conclusion is written pretty much the same way. We can say, we are 95% confident that the true population mean amount students spend on gasoline per week, again adding in the details, is between, and since we're talking money, you may want to round to 2 places, is between $17.29 and $19.77. You got to know how to write that sentence. That is part of the question. Many times doing all the work, you have to be able to interpret it, and that is the interpretation. Now, I've got 6 minutes. I want to show you one other thing, and it really doesn't matter whether I do Z or T, okay? But sometimes you're given the raw data, okay? So if you look at this problem, it looks a little bit different from the others. It says Environmental Protection Agency standards require that the amount of lead in drinking water be less than 15 micrograms per liter. 12 samples of water from a local source have the following concentrations in units of micrograms per liter. And they actually give you the data. They don't tell you the sample mean. They don't tell you the population standard deviation or the sample standard deviation. You could figure out the sample size because I could easily go, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could figure out, not to mention that it said 12 up here. So it does tell me the sample size, and it still does tell me my confidence level. But guys, don't panic. You still have to recognize if you're going to do Z or T, okay? And pretty much with this one, because I have 12 samples, that's less than 30, right? And they didn't tell me the population standard deviation. They would have to tell me that. So I'm pretty much, I know that I need to do a t-test. So I know that for this problem, I want to do a t-interval. Mainly because I don't know the population standard deviation, and we have a small sample. But guys, you can still use Minitab because Minitab, you know, will calculate those other things for you. So we add a step here when we go into Minitab is we just put this data in there and it's going to do the work for us. So don't overthink it, even if you don't give us numbers outright. See, I can come here in Minitab on my worksheet and I can enter, I'm just going to put concentrations because that's the concentrations of lead. Okay, and then I would enter the numbers, 11.4, 13.9, 11.2, 14.5, 15.2, 8.1, 12.4, 8.6, 10.5, 17.1, 9.8, and 15.9. Now, the biggest thing there is making sure, put all the numbers in, put them in correctly. Take a second to double check yourself. But then we can follow the same process. We still go stat, basic statistics, and I'm doing a one sample T. And this time, see, before we did summarized data, but now I don't have the data, so I'm going to do one or more samples. Okay, I have the sample, and I'm going to enter it. And so Minitab knows, okay, I got to do some other calculations behind the scenes before I can do this. We still choose options to tell it the confidence level we want. We want 99. We click OK, OK. And guys, it's beautiful. It does it all for us. Now, and it tells us in the end what the mean and the standard deviation are. I don't need it. Okay, but it does all the work for you. It comes down to choosing, do you have summarized data or do you have raw data? That's the difference in telling Minitab the command in Minitab. Okay, if you have the sample mean, sample size, your standard deviation, then you're going to do summarized data. If you don't and you have the raw data, the list of data, you use one or more columns. Everybody okay? All right, listen to me. Next Wednesday, we are going to discuss hypothesis testing. We will be doing hypothesis testing from next Wednesday to the very end of the semester. You have got to understand that process. I posted, if it's not already posted, it will post, and I have included kind of a note sheet where you can fill in the blanks. That'll make it a little bit easier when you're taking notes next week. Please print yourself a copy of that document, whether you do it here on campus or you do it at home. It's going to make your life a whole lot easier. Okay? I'll see you next Wednesday. Dylan, do you want your test paper? Yes, no?
No, ma'am, I got another class I gotta go to now.
Okay. I mean, I was just going to hand it to you.
Oh, do I have to take it here?
Oh, you haven't taken it?
Oh, no, ma'am.
Okay. You need to get in contact with me then about when you're going to take it, because the test should have been taken last week.
Yes.
So you need to get in touch with me about scheduling to make it